A company architecture consists of a production VPC, a non-production VPC, and a shared services VPC connected via a transit gateway. The design requires that both the production and non-production VPCs have bidirectional connectivity with the shared services VPC, while strictly prohibiting direct communication between the production and non-production VPCs. Which configuration of transit gateway route tables fulfills these connectivity constraints? Option A, create one route table for the production and non-production VPCs that propagates only the shared services VPC route, and a second route table for the shared services attachment that propagates routes from the production and non-production VPCs.
Option B, associate the production and non-production attachments with a route table that propagates routes from all three VPCs, and a second route table for the shared services attachment that propagates routes from all VPCs. Option C, associate all three VPC attachments with a route table containing routes for only the shared services VPC, and a second route table for the shared services attachment that propagates routes from the production and non-production VPCs. Option D, associate the production and non-production attachments with a route table where route propagation is turned off, and a second route table for the shared services attachment that propagates routes from the production and non-production VPCs.
This question tests your understanding of transit gateway routing. Specifically, it asks how to control traffic flows between VPCs when they are all connected to the same gateway. The goal is to enforce network segmentation, allowing specific VPCs to communicate with a central hub while blocking them from talking to each other. This is a common requirement in multi-account environments, where security policies dictate that production and non-production environments must remain isolated from each other. I believe the correct answer is option A. By using two separate transit gateway route tables, we create the necessary segmentation. The first route table is associated with both the production and non-production VPCs, and it only propagates the shared services VPC route. Because neither the production nor non-production VPCs propagate their own routes into this specific table, they lack the path to communicate with each other, fulfilling the isolation requirement.
In the second route table, which is associated with the shared services VPC, we propagate routes from both the production and non-production VPCs. This allows the shared services environment to route traffic back to both. Option B is incorrect because propagating routes from all three VPCs into one table would allow direct communication between the environments. Option C is similarly incorrect, and option D is incorrect because disabling propagation entirely would prevent any traffic from reaching the shared services VPC.